A monster black hole with the mass of 1 billion suns is caught mid-meal, and the picture is stranger than you'd think. The James Webb Space Telescope just photographed a vast tendril of gas, over 1,000 light-years long, funneling into a spinning disk 800 light-years across, where material is racing around at up to 600 kilometers per second. That's fast enough to cross the distance from New York to London in about 10 seconds. But the real twist isn't the speed. It's that this black hole may be eating its own leftovers, recycling gas it spat out earlier. Let's look at what Webb actually saw and what it didn't. The target is NGC 4696, a giant elliptical galaxy sitting at the heart of the Centaurus galaxy cluster, about 145 million light-years from Earth. At its center lurks a supermassive black hole. Using its infrared vision, JWST captured unusually sharp images of gas in the galaxy's core, revealing a long filament of cool, dense material that appears to stretch inward and connect to a spinning disk of gas about 800 light-years wide, circling the black hole's neighborhood at speeds up to 600 kilometers per second. To be precise about what was actually seen, this is not a photograph of matter crossing the event horizon. It's a detailed map of gas structures in the black hole's gravitational grip, gas that appears to be flowing toward it. Researchers interpret this as a fueling channel, a kind of cosmic conveyor belt supplying the black hole with future meals. To understand why this image matters, you need to know about a puzzle called the cooling flow problem. Galaxy clusters like Centaurus are full of superheated gas, tens of millions of degrees, that should, in theory, cool down over time and rain onto the central galaxy in enormous quantities, feeding both star formation and the black hole. But when astronomers looked for that rain, they found far less than predicted. Something was choking off the flow. The leading suspect is the black hole itself. Supermassive black holes don't just consume matter quietly, they also blast out powerful jets of energy that can heat the surrounding gas back up, effectively pushing back on the very fuel trying to reach them, like a furnace that keeps blowing its own kindling away before it can catch. Think of it as a thermostat. The black hole overheats its room, then waits for things to cool down again before letting more fuel in. What JWST may have caught is the cool-down phase of that cycle, gas that has radiated away its heat and is now condensing into a filament, sinking back toward the black hole for another round. This matters because supermassive black holes are not just cosmic drains, they're active regulators of galaxy evolution. If black holes really do recycle their own fuel this way, heating gas with jets, letting it cool, then pulling it back in, that feedback loop could explain why the biggest galaxies in the universe stop forming stars, why cluster cores don't collapse into runaway star factories, and why the universe's largest structures look the way they do. It's a story about balance, an object so extreme it can warp light and swallow stars, somehow acting like a self-regulating ecosystem. And practically speaking, this is also a demonstration of what JWST's infrared eyes make possible. Structures like this filament have been hinted at before, notably in the Perseus cluster, but the clarity here lets scientists trace the gas's motion and geometry in far more detail than ground-based telescopes allowed. Now for the important caveat, because this is where the story is still being written. The idea that this filament represents cooled, recycled gas falling back toward the black hole is an interpretation, a strong and plausible one, but not yet a confirmed mechanism. This finding comes from imaging, not from a peer-reviewed modeling study confirming the full feedback cycle. Scientists still need to measure the gas's temperature history, trace its motion over time, and rule out other explanations, like the filament being freshly stripped gas from a galactic collision, rather than reheated, recycled material. Follow-up observations, spectroscopy to measure the gas's chemistry and velocity in more detail, and computer simulations of the feedback loop will be needed to test whether the recycling theory really holds up. If it does, it would give astronomers one of the clearest real-world confirmations yet of how AGN feedback actually functions, not just in theory, but in a single observable system. So, did JWST really catch a black hole feeding? In a sense, yes, it caught the meal being delivered. What it hasn't caught yet is proof of the full recycling cycle some scientists suspect is happening. But that's what makes this exciting rather than settled. Somewhere in the heart of NGC 4696, a billion solar mass object may be running one of the most elegant feedback loops in the universe, heating its food, letting it cool, and eating it again, forever. We don't know that for certain. But thanks to Webb, for the first time, we can actually see the meal on the table.